Hey everyone. So today I have my Amazon friend who is actually switching over to Meta or has a system design interview at Meta, his on site interview at Meta. But we're going to go completely anonymous. We're going to try to tailor it based on how Meta asks interviews on what we've seen online. So, how does Meta usually ask the system design interviews, by the way? Could you give a brief rundown on how they do that? Because I know you've been looking a lot on the different blinds
Mhm.
and like, yeah.
So basically, from what I read and what I heard from my friends, it's like a 45-minute round for the designing part, and we will be given at most 35 to 40 minutes to design the high level, to do the high level design of the system.
Hmm.
So that's the basic structure of it, and last 10 minutes is reserved for deep dives. If it's 30 minutes, last 10 minutes is reserved for the deep dives part.
I see. Okay. And you're feeling super confident about the coding. You've probably done like over 500 lead code questions at this point,
Yeah, I am confident with my coding skills. Yep.
and you've spammed coding interviews already, huh? Like, I mean, you've
Y-
spammed meta top tag questions and stuff, right?
Yeah, I spammed like crazy. I did like
Hmm.
340 something, just
Wow.
350 something, just in tag. Yeah, coding I am not super worried about, but system design is something I am a little worried about because I come from networking background from
Okay.
Amazon.
Yeah.
I was in the core networks team building the network operating system for AWS.
Okay, cool. So I guess this one we're probably gonna keep it more infrastructure focused
Hmm.
because they offer two tracks, right? The product focused roles
Oh
where it's
yeah.
yeah. Could you explain that?
Oh, so Meta does two types of system design interviews, the product one and the infra one.
Mm-hmm.
And for the product one, it's almost every time guaranteed to be a product question, like design lead code, design some app, user facing app. And for infra, it's mix of 60% product and maybe 40% infra. And the infra parts would be like ad click aggregator, web crawler, something stuff like that. They do
Mm-hmm.
these two types of interviews based on the role we are applying. And basically, the product ones are are offered to people who did front end stuff as well. If
Mm-hmm.
someone's general backend, they will be like asked to do the infra loop.
I see. Cool. All right. Yeah, we're gonna like you mentioned, you only have 45 minutes, so
Hmm.
assuming we only have 5 minutes for intros, we're gonna try to have maintain a good pace, right?
Hmm. Yep.
And since you're in the infrastructure track, we'll probably keep it more infrastructure. So even if the question is related to some product, we're
Hmm.
gonna dive deeper into the infrastructure portion. I want to get a sense of what you know there. Okay,
Yeah.
cool. So you've been spamming lead code.
Hmm.
Let's design lead code.
Okay. Yep. Sounds good. So yeah, I'm starting, and
Sure.
basically we are designing lead code. And I have a few questions here. Are we designing any specific feature of lead code, or are we designing the lead code itself, like basically the contests or just the problems to solve stuff? Are we designing any specific feature?
I would say, yeah, probably just focus on. I mean, maybe you could propose something and then we could figure out what's below the line.
Hmm. So yeah, basically the question is a little vague. I want to get a gist of. Okay, let me write some functional requirements down.
Yeah. I'm just curious or yeah, maybe you could propose like some features.
Okay.
If you don't know much about the product, I can explain it, and then yeah.
Hmm. So yeah, I know about lead code. So basically, lead code has a set of problems that we can solve and see and get a submission or something. Basically, saying how fast we solved it and how better we did based compared to others who have solved the problem. And it offers various different languages to code in.
Mm-hmm.
And the other part of lead code, which is interesting, is the contest part, where it runs weekly and people join and take this contest, code up, and get a and see the leaderboard and get a rank from the contest itself. So we can see what we wanna discuss.
Yeah. Yeah.
Are you done
Probably
then?
just the core features of LeetCode.
Hmm.
And below
So,
the line, we could talk about contests, but I mean, let's
mhm.
focus on. I mean, that would probably be more on the product side. So let's just focus on the core.
Mhm.
Yeah.
Yep, got it. So basically, in the beginning, users should be able to see the problems, able to see the set of problems,
Sure.
and users should be able to filter them based on their preferences like tags, difficulty, stuff like that.
Mm-hmm.
Based on tags,
Mm-hmm.
difficulty, etc., and stuff like that. And users should be able to code up their solution in their preferred languages.
Mm-hmm.
Oh, uh, users should be able to filter them based on tags and all, and users should be able to see the problem, see the test cases, and see examples that are given, like the problem description part
Mm-hmm.
of it. See problem description, and users should able to submit. Okay, write code and get feedback and get feedback. I basically mean the part where did our code pass all the test cases and how fast it is,
Mm-hmm.
stuff like that.
Sure.
So, and yeah, and there are other features like aggregating all these things in the user account to basically track how many problems they solved, stuff like that. Is
Mm-hmm.
it under the line, or is it something we need to work on as well?
Yeah, probably below the line.
Hmm. So yeah, and based upon my functional requirements, user should be able to see the set of problems and filter them. User should be able to select a problem and see the description. User should be able to code and get feedback. So these are my core functional features, functional requirements of the system.
Cool. Yeah, makes sense. And I'll let you
Yep.
try to lead the
Mm-hmm.
conversation too.
Yep. And I just want to get through the non-functional requirements as well. Basically, hmm, hmm, I'm thinking about okay. Since we want high availability compared to consistency, because we should be able to serve people, and if we cannot, if we are offline, it's an issue rather than like showing few like a second or two in their submission history, being inconsistent like that. We would I think we would concentrate more on availability greater than consistency. And
Why do we have to make that trade off?
because we want our platform to be available instance, we want our platform to be accessible by the users rather than just sometimes showing wrong, like a delayed result, or delaying our result for maybe like 5 seconds or so,
Mm-hmm.
or maybe having some inconsistencies in the result is
Mm-hmm.
something I want to let go compared to being available all the time.
Mm-hmm. Or I mean, how come we can't have both, and how come it is a trade off?
uh so we want partition tolerance for sure. So from the cap theorem we can only hit two of them basically, uh, two main parts of it.
Mm-hmm. And how? Like why?
Mm,
Like, could you quickly just briefly explain the cap theorem and why you could only choose two? And
Oh, so CAP theorem basically is consistency, availability, and partition tolerance.
Mm-hmm.
And a system can't have all three of them m- in most according to the theorem, because if we are available all the time, we need to have some sort of thing to fall back on in terms of partition tolerance.
Mm-hmm.
A highly available system should be fail proof, and
Mm-hmm.
yeah.
Okay, makes sense. Yeah, we can move on to the next one. Yeah, prioritizing availability over consistency
Mhm.
makes sense. What else?
And yeah, maybe this we can even discuss further, maybe dividing it into my like my micro architectural stuff, dividing it into two different microservices, and
Mm-hmm.
maybe try to hit most of them, but at a high level I want to prioritize availability more than consistency.
Okay, sounds good. What are some other non-functional?
uh, Security and isolation. uh,
Mm-hmm.
So our system should be secure because we are letting user lot of user code to interact with the system, and we are compiling it, right? So we want it our system to be secure from malicious data or someone basically making it what an infinite loop, or some malicious code that might be pushed onto the system or something. So we should have strong security and isolation for code submissions while
Sure.
submitting the code and compiling the code.
Mm-hmm. Okay, makes sense.
And submission and low latency in the sense we should be giving out the result in a reasonable time,
Mm-hmm.
maybe under 100 milliseconds or something, which is acceptable. So a low latency is something I want to have in my system.
Sure.
Maybe I would say when compiling the code 100 milliseconds.
So low latency when it comes to getting back the result, or
Yep.
okay,
Yeah, getting back the result.
sure. Okay.
So low latency for searching and submission feedback as well.
Mm-hmm. Okay.
So yeah, I think these three are the most important functional requirements.
Mm-hmm. Is there any sort of edge case non-functional requirements?
Edge case. So how many like the languages? How many languages do you want to support? There can be some weird languages that someone wants to use. Can
Mm-hmm.
we skip that?
Okay. Well, I'm thinking more of like pretend a bunch of people submit at the same time, or there's a contest that just started. Like, do we?
Oh, it should be highly scalable as well. Yep.
Mm-hmm. Okay. Yeah. I think also what I was getting at is like we should handle surges in traffic, right?
Yep.
Yeah, highly scalable for sure, but specifically for surges when a contest started, a contest about to end, everyone's just you're
Oh,
gonna get
okay.
way more than usual, right?
Yeah, yeah, yeah. So I was not writing it because we discussed it. It's just the basic lead code. If it's contest, yeah, we
Mm-hmm.
should prioritize searches.
Okay. Yeah.
Yep.
Okay. Cool.
And core entities would be users, code, submission, and in terms of contest, we need a leaderboard as well. So do we want to include competitions as well, or
No, no, we don't have to do it. But yeah, just still want to eventually talk about surges because, I mean, regardless of competition,
Mhm.
like if people decide like if something a blog came out on a new question or something and everyone wants to do it, you might get
Oh
surges
yeah.
still.
Mm. So I think these are the core entities. We have users, code, and submission.
Okay. What is the code one?
Oh, users, uh, basically the questions and the user submitted code. The code that the users submit.
I see. Okay. Yep. Move on to the next part.
Yep. So I want to go with the API signature, API signatures.
Mm-hmm.
Hmm. User should be able to see set of problems. So user should be so it should be a get endpoint. User should be able to see set of problems, view problems, and basically it would take in. Okay, we can combine the first two steps into one. Users can basically view based on, they can pass in optional parameters like difficulty and topic which they wanna go, and get a set of list of problems, list of problems, and and then other get endpoint to view a specific problem. Based on problem ID, they should be able to see it. And
So, just have a question. Would be, what would be, what kind of API is this going to be?
uh, which one? As of now, I am just considering REST APIs.
Okay.
And view problem, we will get a list of problems, and using the problem IDs, we will look into the problem and submit submit the code. Basically, code blob to take in problem ID and the and code blob, and if some optional fields like languages, etc., and it would return the submission feedback. It would return the submission feedback.
Mm-hmm.
So these should be our main API calls that we will be looking at. Users should be able to view problems. It would return a set of problems based on the tags which they added. If they
Mm-hmm.
don't add anything, we just display all of them based on our numbers. And next, user with the problem ID, user should be able to see a specific problem, and user should be able to submit code for that problem ID. And maybe we should also pass in, yeah, user ID, problem ID, and code blob, and the language optional fields like language which they want to add, and get a submission feedback.
I see.
So
Any that makes sense. Any security issues there with passing the user ID into submission?
uh no, we should not be passing that. No, yeah, we would know who's sending them. So yeah, we should not be passing the user ID itself in the submission part. Yep,
Hmm.
I was a little wrong there. Yeah.
Okay.
And
Well, go ahead.
and at this point, I want to touch up lightly on what type of database I want to use, but I want to fill up the columns and everything during my high level design part. Is that fine?
Okay. Yeah, sure. Yeah. Maybe we could go to the high level design if you want to.
Mm-hmm. Yeah, I want to use relational databases because I see relations between uh, I can relate. I can have relations between the columns. I can link them together. So I am thinking of using a relational database, and I am little familiar with Postgres, so I would say
Okay.
I would go with Postgres, but I will make changes based on the high level design part.
Sounds good.
Yep. So at the in the very beginning, we would have a client. We would have multiple clients, and all these users would go through a load balancer slash API gateway. Let me write that down. API gateway, which would take which should take care of the authentication part, and load balancer, mm, L4 comma L71, and take care of routing slash ACL forward embed, and yeah, it's a basic load balancer, and I'm just considering like the routing protocols, like the routing features as well. But basically, our request passed to the load balancer, and it would hit our mm, lead code service, and we would be polling on the database to get the problems. Mm. But in terms of security end of things, yeah, let's say client sends get request to get all the problems. We can hit our lead code service and get them from the database and return it back to the user.
Makes sense. Could we just quickly, just like write the
Mhm.
component name for each one, just so
Yep,
I'm
yep,
not
yep,
confused?
yep.
Okay.
Service and DB. So yeah, one thing we discussed in the beginning was we want to be secure and not push the entire code into the lead code service itself, because it can be malicious. So I want to have a separate service for that, which would handle all these code compilations and would write them back to the in the database, or send them back to the service to write it back in the database,
Sure.
so that we won't be giving them access. Yeah. So hmm, okay. So whenever user submits the code, it can hit our secondary service, and we can compile the code here, and we can have multiple virtual machines in there, basically for Python, for Java, for for everything we need. We can have multiple virtual machines in it, and it can run the service, and basically run the code, and basically send the results to the lead code service to write in the database. Mm. And yeah, and I think so the co and we should also restrict how much we can also have some security features here in the virtual machine, basically saying uh, if it takes more than 2 minutes, just send a fail message, or we can lock it for a bit. And okay, let me just write that down. Okay. Uh, we should be limiting the resources that a particular code uses. We should stick to some sort of resources, some sort of CPU allocated specifically for that part of code. Limit resources, network isolation slash namespaces, network isolation slash namespaces. And yeah, we can TTL, like we can have a timeout for each session. Since these are all different virtual machines, we can have a time limit. Let's say if the code runs in 1 minute, it's fine. If it doesn't, let's just send a, end the process there, like specifying a certain limit for a user.
Mm-hmm. Okay.
And there is also a problem I see. If the code is too large for us to directly push onto the secondary service, so we can also maybe have an S3 to basically push the code in it and basically get a link for the code.
Mm-hmm. But you'll
And
still need to bring that code to the secondary service to run it, right? Or no?
uh, do we need to? But okay, we will be bring okay, we can have a queue or something to basically limit that. If we will bring the code, but the thing is, if we have a lot of user requests for submitting the code, we might exhaust this service, no?
Mm-hmm. Makes sense.
And yeah, and I think we can all okay, we can also we can exhaust this service, basically running out of virtual machines and all. We can use some auto scaler to auto scale if we need more resources and limit them if we don't need them. We can add an auto scaler
Mm-hmm.
to scale automatically. Mm, something like Amazon SQS or AWS SQS or something to
Mm-hmm.
scale automatically scale them. And we also would also be using a pub/sub kind of a thing to move the code to the secondary service to complete the execution part.
Mm-hmm.
SQS to scale, and maybe mm, pub/sub queue or something.
So what's SQS is? So we have a pub sub and SQS,
Oh,
or it's not?
no, no, we can just have this SQS itself. Sorry, we can just have this SQS. Our code hits this, and yeah, and it basically, yeah, acts as a queue to move the data, and it has auto scaling as well in it, so we don't need to have both.
What has auto scaling the SQS?
SQS.
Okay.
And yeah.
Mm-hmm. Okay. So okay, let's see. There's some questions then.
mm,
Unless you have other things you want to cover.
I'm just looking at it. I will Let me just go through it again. Client
Mm-hmm.
sends a request, it hits the lead through it goes to the load balancer and API gateway. It's the lead code service and gets the problems they want.
Mm-hmm.
Once the client completes the problem, like codes submits a code, it hits our SQS, it hits our queue, and sends it to the S3 to convert it into a link if it's needed. But this thing we can remove it, but it will basically send them in order into the secondary service, and it would compile them based on the language. Based on the language you want to complete, like compile the code in, and it would
Mm-hmm.
send the result like how much time it took to the lead code service, and it would write into the database and send it back to the user, send it back to the client. But this S3 part we might not require it as of now.
Okay. So yeah, continue.
And the other part with this secondary service which would run our codes is should limit resources, user isolation, and it should have a TTL for every session.
Okay. Is there any other things we need there?
In the security part or in
Yeah,
the high level
security
design?
security part. What do we mean by limit resources?
Oh, if it takes more than, let's say, 20 MB of space to store the
Okay,
code, and maybe to store, and
I see.
if it's taking more RAM to run it or something,
Okay.
we can limit the resources. And network isolation,
Okay.
limit each user for this TTL sessions
Okay.
for the 1 minute. And do we need anything? Let me just go back to my, okay, security part. We covered it, and we are not pushing the code directly onto the first service. We are pushing it into the secondary service and compiling it.
Hmm.
So I think we are pretty good on the mm,
Yeah.
security part.
What, could you quickly explain the network isolation and namespaces? What is that covering?
Oh, basically, we are giving separate bridges for since these, I failed to mention, these are different virtual machines like Docker containers or Kubernetes clusters or something. So everything has this own separate bridges and separate chunk of network to run in instead of running it in the same network itself.
Hmm.
Let's say we make a separate bridge for that particular user when he's on the
Hmm.
uh, when he's compiling different namespaces, different net isolation points for them
Hmm.
to code in.
Do we want them running network calls there?
Uh, so
Like for leak code?
mm, we don't want. Okay, okay. This can corrupt everything. Basically, different virtual machines, right? If they're all running, if one of them fails, all the other in the same network would fail, right? So these are not high level network isolation calls. These are just basically creating namespaces. I think that would be needed for additional security. But the main drawback is if there is any virtual machine that corrupts or drops uh, at a very low level, if it drops traffic or if it starts failing and increasing, triggering a like reboot or hard restart or something in that particular network,
Hmm.
we might run into issues. But that's a very deep level case.
I see. Okay. Yeah.
But this is a super easy one to make. We are not making super deep network calls. We are basically creating namespaces for different virtual
Yeah.
machines.
Okay. Makes sense. Yeah. I'm thinking more. The other one that I was thinking more of here is just like safe, making sure the host system is safe as well. Like, do we want to stop the virtual machine from doing anything on the host?
uh, Doing anything on the host.
Right. Like, pretend I have a computer and I'm running virtual machines.
Mm-hmm.
If that virtual machine could like run on my computer, like
Mm-hmm.
the host system, there could be some problems, right?
Yep.
So yeah, that'd be one thing. And then one thing I want to just pull into is like, okay, you mentioned virtual machines, that you mentioned containers. Are those different things, or it's the same thing?
Oh, they're different things.
What would we
Oh,
want to use
sorry.
here?
Oh, I named them at the same context, but yeah, each of them is a separate Docker container. They are the same thing. Virtual machines are, but Docker it okay. With Docker, we will be what using the same OS without creating new virtual machines. We will be segmenting them using the same operating system. Using the same resource, we'll be using the same resource for everything. We won't be allocating separate resources for
Hmm.
separate virtual machines.
Okay, what's the advantage of using like containers versus virtual machines here?
Oh, virtual machines need their own set of resources. but Docker containers and these share the resources with the main host.
Mm-hmm. Okay. Sounds
So
good.
yeah,
Cool. Yeah. So we're gonna go. So you want to go with VMs or Docker?
yeah,
Okay.
Docker containers. I did not write them.
Okay.
Yeah,
Sounds good. Yeah. Okay. So we're gonna do containers
Python
instead of like
and
full VMs.
yeah,
Makes
yeah.
sense. Any other thing that you want to consider? I think we have like 10 minutes left, so I'm let you guide more of the deep dives as well.
Okay. So isolation handle highly scalable. Yeah, uh, we handle scaling by adding this auto scaler thing. SQS has auto scaling. It would scale if we need more resources. We can scale in this code submission part as well, but handling high surges during high surge events.
Mm-hmm.
Is the system good with high surges?
Yeah. Like actually, yeah. Where will be our point of failures if there's a surge?
Yeah, so I think our point of failure would be lot of people would be hitting our lead code service to get the questions, to look
Mm-hmm.
at the questions, no?
That could be one,
Uh,
but I don't know if I'm too worried about that one because
mm,
yeah, those are like quick queries. I mean, LeetCode only has like 3,000 questions, right?
yep. And the other point of failure would be with this SQS, with the when compiling the code, if lot of users run a lot of code in, like, let's say maybe around 20,000 people submit the code or compile the code at very close intervals, we would run out of resources. We would need to scale up more resources in the secondary service.
Okay, we need to scale. So how do we do that?
So we can horizontally scale, but yeah, we can auto scale. SQS auto scales adds new services, but I am talking about the point where we ran over the limit of the host
Yeah.
itself. We need
No.
more
Yeah, I
path.
agree. Like how would we know when to scale it and how would we scale it?
Oh, if this is okay, if this queue is full and we don't have resources to run, maybe we can check we can have a worker basically checking the resource, the utilizations and everything on this particular thing. If it crosses over certain threshold, let's say 75% or 80%, we can horizontally scale it, huh?
Okay.
And another one would be we can, yeah, as I mentioned earlier, we can use, so we can reduce one of the resource. For the code part, we can have the code in a separate S3 and different workers. Okay. Mm, okay. Regarding the memory constraints, when we are running the code, we can use the S3 link to get the code and compile it instead of having the code all the time on the secondary service.
Hmm.
That can be a little helpful, but I don't think it will be super helpful.
Well, I think with when it comes to bringing the code from S3, right?
Mm-hmm.
We we still need to load that in when we're talking about memory here, right? We're talking
Mm-hmm.
about the memory on our container. We don't want it to use up too much memory, but like we're gonna have to load in that code into the Docker
Oh,
container. So
mm-hmm.
I think maybe that's not the concern. And when we shut down the Docker container, we could free up that memory. Like that could be handled.
Mm,
So I think that part's not really my concern
yeah.
there. Of like the code running and how big can code even be? Like pretend I have 1,000 line
Yeah, not more
code.
than 10 MB or 20 MB. Not
Mm-hmm.
more than few like 5 MB to 10 MB maybe.
Mm-hmm. Okay, yeah. So yeah, I wouldn't really consider that. So for your load balancer, you did
Hmm.
mention L4, L7. Which one are you thinking of using?
Oh, there are hybrid load balancers which would support both L4 and L7.
Mm-hmm.
So we can have a hybrid load balancer. Basically, at layer 4, we would be doing the ECMP forwarding, the ACL based filtering stuff, and at layer 7, that can be like the normal application layer stuff. We can have
Hmm.
both of them, and
What
maybe
would
SSL termination. Huh?
what would be the normal application layer stuff?
Based upon the load balancer, right? Uh, Scaling the okay, horizontally scaling stuff with the clients, basically balancing the traffic between like the requests on how many requests that. Okay.
Hmm. Yeah. Like we L7, L4
Hmm.
operate at different levels, right?
Yep.
Like, why would we want to use? Why would we need to like given a request?
Hmm.
Like, what would be the use of using an L7?
Okay, it would basically uh, balance it by sending it to different different services from we like instead of overloading a single service, we'll be dividing the load between services at layer
Hmm.
7, right?
What about L4? I mean, they're both load balancers, right?
Oh, L4, we will be basically forwarding based on the traffic that we are sending, equal cost multiplier path. Basically making sure all the links are forwarding the same, like equal amounts of traffic, that no link is getting overloaded.
Okay.
And this is kind of helpful because uh, L4 is basically like the network layer, and their segmentation would happen, and we would basically link traffic to the application that needs to go in, and ECMP forwarding would basically help there.
Hmm. Like the part I want to pull into would be okay. We you have a microservice architecture. Right? You have a secondary service and a leak code service. How's
Hmm.
my load? If I have an L4 load balancer, how's it gonna know which server to send it to? Which service?
How would my L4 load balancer know which service to send it in,
Yeah,
right?
like yeah,
Is the,
which service to route it to? Like, is it gonna route it this way or route it this
oh
way? Like in the
no,
L4 level.
oh, at L4 level, each request is segmented into, like, let's say, lead code service. It has a number of segment 200,
Mm-hmm.
or let's say, I don't remember the names. It should be like segment 59 or something.
Mm-hmm.
So basically, uh, the request has a header saying the segment number as well.
I see.
Segment number 59 should go to lead code service. Maybe 60 go to the secondary service.
Okay, sounds good. And then one part, could you just quickly walk me through? This is a little bit on the product side, but I kind of want to understand your thoughts on, or like how you think about the request to response flow. So just quickly walk me through a client submitting a problem and eventually getting feedback.
Hmm. So client sends a HTTP GET request, and it passes to the load balancer. Okay,
Mm-hmm.
get get request, and it passes to the load balancer. Hits our lead code service, and our lead code service uh, queries our database
Mm-hmm.
and sends the response back the same way it came in. Total problems, the problem set which the client wants to see. Now the client wants to submit a code. Client sends a post request, and it would be added to our queue for processing, and it would be processed in the secondary service.
Mm-hmm.
And once it's complete, we will basically get time taken to complete and memory
Mm-hmm.
to complete a memory taken kind of thing taken, and we would send it to the lead code service, and it would write it to the database, and we
Okay.
would write time taken and memory and stuff.
Okay. So, and then what? The leak code service will kind of send that back to the client.
Yep, the lead code service would send that back
Mm-hmm.
to the client.
But like
Send
as
the
a
submission.
client, right? I made a connection with this guy or the API gateway,
Hmm.
right? So like, how is it gonna? how is this full loop gonna happen? Like it's talking to multiple services there.
Okay, this client is gonna send a get send a post request and it will hit the secondary service, right?
Mm-hmm.
So once it compiles, the secondary service writes it to the sends it to the lead code service to write it in the
Mm-hmm.
database.
Okay, but the leak code service, how are these two communicating? How is the secondary service communicating with the leak code service? Just sending post requests? Do they have like direct connection? What's happening here?
Oh, okay. Let's not have a direct connection between them. We can write the time taken stuff in the database itself, no? I'm just thinking.
Mm-hmm. Because like from what I know, like the client makes a connection over
Mm-hmm.
here, but then all of a sudden, like how is this leak code service going to be able to know where the client is? It's gonna send a push request to the client or something, or that's what I'm trying to get at. It's like you made the request here. Usually, the same server you sent the request to should respond, right? Because that's who
Mm,
you made the HTTP connection with.
yep.
Yeah, I think
How,
yeah
how
we could probably go over that on the thing, but yeah, just trying to poll. But we're at the 45-minute mark. How do you feel
Mhm.
about the interview?
I need more preparation.
What parts do you think you did good
Hmm?
on, and then what yeah like yeah how are you feeling overall? Like which parts did you feel comfortable with, and then which parts do you think you kind of struggled with, and yeah like yeah.
Yeah, the parts I struggle with is I can talk about what are needed and all. Like I know the structure, how to follow, what to follow in an system design interview, and how to write them down. But I don't know a lot of stuff about what I am writing there. If I get a cross question, I might fumble. I fumbled a lot of times.
Mm-hmm. Okay.
So the places where I struggled is basically when we dive deep into how the requests are made and st-
Yeah.
stuff like that. So
Cool.
the stuff I don't know that basically makes me panic and answer wrong.
Mm-hmm. Okay. Sounds
Yeah.
good. Yeah, I have some notes. So what I'll mention is yeah like I tried to pull into some of the stuff, and I think
Mhm.
they actually might ask you this stuff as
Mhm.
in the interview. Is if you mention
Yeah.
available, like if you mention the cap theorem, and
Mhm.
I tried to pull it a little bit a little bit into like if you understood it, but
Mhm.
then there like it didn't seem like that you understood the theorem, but not exactly why that theorem
Mm.
even exists. I could explain it quickly.
Yeah.
So are you following my mouse?
Yeah. I'm following your
So like
mouse.
yeah, if we want partition tolerance, right? So that
Mhm.
means we want multiple partitions.
Mhm.
If, so pretend we have a client who needs to talk, and we need partition tolerance.
Mhm.
Pretty much, if we want consistency, or pretty much if we want availability, we have to trade
Mhm.
off consistency,
Uh huh.
because if we need to replicate the data, right? Pretend when we do a write here, the data, it
Mhm.
needs to get replicated to all of the other ones,
Mhm.
right? But what if this connection goes down, right? What
Mm.
do I do? That means I can't talk to this server, so I can't. So essentially, I need to wait until like essentially it has to be eventually consistent in order for me to like talk to any of the servers, right?
Mhm.
Other than the primary.
Yep.
Does that kind of make sense? I
Yeah.
did a
Yeah.
bad
Make.
explanation there, because yeah, like consistency. What does consistency mean in this portion? It means that all nodes have the same exact. Like, what does consistency mean? It means all nodes have the same exact copy of the data,
Mhm.
right?
Yep.
But if there's a network failure,
Mhm.
then then we lose consistency if we want availability. Because if we
Mhm.
want availability, we should be able to talk to any of the nodes, right?
Yeah.
Because what if
Yeah.
this goes what if this goes down and then this goes down? We should be able to talk to any of the nodes, but
Mm.
the data hasn't been replicated there yet.
Yeah.
So that's kind of the trade-off there. So yeah, if we want strong consistency, what we can say is if there's a network partition, we wait till it goes down or it goes back up. Like if there's a failure,
Mhm.
we wait till it goes up. but that means we lose availability because we have to wait for it to go up and
Mm-hmm.
then to replicate. That makes sense. I think
Yeah, yeah,
yeah,
that makes
you could
sense.
investigate it a bit. Like I don't know if I explained that well there.
Yeah, I understood. Yeah, I will look at it. The
Yeah.
thing is, I understand these topics at a very high level. I can't go deep.
Yeah, I
That's
mean,
the problem I have.
I didn't even go deep there. That's kind of I would just explain it like that, like a little 1 to 2 minute. Like
Yeah.
I even did a bad explanation there. Um, I need to refresh myself a little about that, but usually that's how I draw the diagram. And then related to your endpoints, I think you need to use better REST API principles.
Yeah, yeah, I have that too. I know that feedback too. I
Yeah,
did not work on any REST APIs in
yeah,
this entire 3 years. So I just stick to just basic function calls and return
I see.
statements.
So usually you would specify like get the specific
Yeah,
resource.
yep.
So the resource would be like a submission. Like it would be these would usually be the table that you're talking about, right?
Hmm. Yep.
So
So,
because you're saying get endpoint, usually you'll be like get problems or
hmm,
get problem instead of
yeah.
get endpoint.
Yep. So one of the reason I wrote them like that is instead of trying to write them like resources and stuff and messing it up, I cannot mess this up. It's basically I'm saying I'm using a get endpoint, and I'm just saying what my function is doing basically.
Okay. Okay.
But it's a bad thing to do. I need to move to this resource style of
Yeah.
telling, but this is guaranteed to not fail.
Okay.
Uh,
Yeah.
uh, what do you think about that, James?
Mm.
Because I am scared that I might mess up the syntax and look so what?
I mean, like next time we'll do another one and just we'll just make sure that yeah, I would just if you're introducing REST APIs,
Mm-hmm.
I would just use RESTful practices.
Mm-hmm.
You don't really need to go that deep to it. You could just be like get usually it'd be like get problems
Mm-hmm.
and then returns like a list of problems.
Mm-hmm.
And you can get oh, sorry get a problem and then specify the problem ID, right? And that returns like a specific problem.
Mm-hmm.
Like that what I would say my advice would just be like, yeah, it's usually just like a verb, right?
Mm-hmm.
And you know the verbs, but
Yep.
definitely like all you need to worry about is like the resource and then the different path parameters.
Mm-hmm.
Path parameters are like the IDs, and then query parameters if you want it to do certain filtering. So I think those are the main ones you just need to know. And
Yeah.
I think you would once you know it, you'll be able to list it out faster. And it's a bit for me, it's more it just confused me a bit on how you're doing
Okay.
there.
Mm-hmm.
Um, one thing too would be also just mention whenever you're like doing a big get request, like you're getting
Mm-hmm.
view problems, we should also consider pagination. And it's
Mm-hmm.
since it's a infrastructure focus, maybe they won't care about that. But I would just mention that
Mm-hmm.
like pagination would help here because yeah, like they don't need the full list every time.
Yep.
You mentioned relational versus Postgres because the data is or because you said it's highly relational, but I don't think that the data is that relational. Like any would work, so I don't know if I would mention that. I mean,
Mm-hmm.
the most relation is between the code and the question, but that's like one level. It could easily
Mm-hmm.
be done in a Postgres database too.
Mm-hmm.
Versus like I don't know, there's like way higher relational data that you could work with. Then yeah, this is kind of flat still.
Mm-hmm.
Let's see. Then I would say yeah, definitely like um, making sure to mention VMs versus containers. Like VMs are way more heavier. Like
Mm-hmm.
they do spinning up a VM is way more effort.
Mm-hmm.
Like it needs much more resources versus containers are more lightweight.
Mm-hmm.
So definitely like I would make sure to bring out that point.
Yeah.
And yeah, also let's see what else. Yeah. Um let's see. Probably lastly, I would say yeah, just kind of understanding the request to response flow. So
Mm-hmm.
like you make a request here. I mean, we'll probably have some server that's going to put it into the SQS queue.
Mm-hmm.
right? There's some server that handles the request and adds it to the SQS queue. Then yeah, these secondary servers will pull the SQS queue and
Mm-hmm.
eventually like update the database. But from the client side, we would probably like as soon as we put it into the SQS queue,
Mm-hmm.
we'd probably create the submission in the DB and put a status of like pending, and have the client pull the lead code service to see when that submission is done,
Okay.
right? Because your way was like I kind of sent it to SQS and then it got to lead code service. It eventually got back, but that's like a
Mm-hmm.
pretty complicated loop. Like how is the lead code service going to talk to the client here, right?
Oh, yeah. We can have something like connection stable in the lead code service itself, basically sending it back to the thing. But yeah, the service one is better.
Yeah.
Something
Yeah.
like connection one, user two, user three, a table like that, and it can send it back. Huh?
Or yeah, I can go through in a different video of like how we could do asynchronous jobs, because that's
Mm-hmm.
essentially an asynchronous job. The client wants you to run a job. They don't know how
Mm-hmm.
long it's gonna take because imagine it surges. It's gonna take longer than usual for it to
Mm-hmm.
eventually run the submission. But the client should just send off that request, and then they should be able to poll for progress to see when it's done
Mm-hmm.
to handle those surges. Like depending on like it depends on how you do it. You could also make it completely synchronous,
Yeah.
where the client just like runs it and then returns it, or like the
Mm-hmm.
same person that got the request will respond. That's the more
Mm-hmm.
synchronous one. But I think if we want the code to run for more than a minute, we'll probably have it asynchronous. So those are the
Mm-hmm.
things that I would mention, and then also here I think what for the security we want to probably limit network calls. We don't want it sending net. We don't want the lead code questions making network requests because then they can like do malicious things if they can access the internet, right? They can create like some lead code,
Oh,
or they can. Oh, go ahead.
it's not. We won't be making any calls. We will just be setting up the namespace. It won't be something that is super accessible. It will just set up a namespace whenever we're running.
Okay.
Uh,
Yeah, I see.
it won't take so much. It's just a command that is internally, like we need to just enable it. If we enable that, every time code runs on a Docker container, it creates a namespace specific for that. We just need to enable it.
Okay. Yeah. And then what I would say is just also limit like the limit security would also make sure that the containers can't access the file system of the
Mm-hmm.
host. Like when you have a host service and then you have containers in it,
Mm-hmm.
you want them running on their own file system and not the underlying file system or under like you don't want it to affect anything on the host because it can bring the host down. So
Mm-hmm.
that's one thing that you need to mention here.
Yeah.
Yeah, but cool. Yeah, I think that's probably everything. I'll probably stop the video here, but yeah,
Mm-hmm.
stop the video here and then we could talk about stuff afterwards as well.
Yeah.